Hi everyone. This is my first YouTube video and I decided to talk about the Langchain. There are many videos out there, but I wanted to share my own view, simple and developer friendly. And if you are starting your AI journey, Langchain is a great place to begin. It's like the hello world for AI apps. It helps you learn the basic ideas easily, and once you understand it, using other tools becomes much easier. I hope this video helps you understand better. So let's get started. Many apps are built using large language models or LLMs. Apps like Cursor, Lovable, Bold are specifically for the vibe coding, and Midjourney for the image, Runaway is for the video generation, and N8N is more sophisticated workflow automation. So these apps takes your input and send it to the LLM like OpenAI or a Claude and then show you the results in a nice way. So each product can use any different LLMs of their choice. From a developer perspective, the challenge is that when a product needs to switch between different LLMs, say from OpenAI to Claude or Olama, they often have to rewrite or adapt their code to make it compatible with the new model. And each LLM has its own API, times even different response formats. This makes switching model a time consuming and error prone process. But what if there was a way to make that switch seamless? What if you could build your app once and then easily swap out the underlying LLMs without rewriting everything? That's exactly where the Langchain comes in. Langchain provides a unified interface to interact with the multiple LLMs. It abstracts away the differences between providers so developers can focus on building their application logic without worrying about the specifics of each model. Whether you are using OpenAI today and want to try cloud tomorrow, Langchain makes this transition smooth and efficient. This flexibility is a game changer. It means products can experiment, optimize, and even personalize their AI backend, choosing the best model for the task, the budget, or the user without overhauling their code base. One of the best things about Langchain is that it lets you build your own AI apps. Whether you are working with RAG, famously called retrieval augmented generations, or agents, which we will be seeing further in the topic, without needing to worry about the technical details of the LLMs. So you don't need to understand how each model works or how to connect to them. Langchain handles all of that for you. It gives you the tools to focus on your app's logic, features, and user experience, while it takes care of talking to LLMs in the background. This means faster development, easier testing, and more flexibility to switch models or add new features, all without deep AI knowledge. Langchain has some of the useful features to make the app easy, like chat models lets users talks. The user talks to AI in a natural way. So in the messages, it keeps track of the conversational flow, helps guide the AI to give better answers. The prompt templates. It has a short-term memory where it remembers the past messages to keep the chat smooth. It also has tools adds extra functions like search or a math to make the AI smarter, shows responses live as they are being created using the streaming. Structured output organizes the AI's response into a clean data. So all of this makes it easy for developers to build the smart apps quickly. Langchain handles the hard parts, connecting to LLMs, managing responses, and adding features. So developers can focus on creating great user experience. Langchain is made up of different packages that helps organize its features and makes it easier to use. Langchain, this is the main package, includes all the important parts which we have discussed in our previous slides. The next is the Langchain core package. This package holds the basic building blocks. It has a base class for models, tools, and memory. It defines a standard ways to work with messages, prompts, and the other parts. Everything in Langchain follows these core rules to stay consistent. And Langchain community package, this is where the community adds new tools and integrations. It includes third-party tools and connectors. These are not managed by the main Langchain team, but are still useful. And it's separate from official partner packages like Langchain OpenAI, Langchain Google, Langchain Hugging Face, which comes directly to the Langchain package instead of the Langchain community package. So this is something you we have to keep in mind. So there are also extra packages like Langchain text splitters helps breaks down the documents into smaller parts. MCP adapt adds support for Langchain agent system. Together, these packages make Langchain flexible, modular, and easy to use, whether you are building a simple chatbot or a complex AI agent. Let's quickly see Langchain in action. So probably I'll be using this as one of the first tasks, and I will also show you how to do it in the Visual Basic or in different editors using the Langchain. Okay, here is the first task where we'll be creating a chatbot using a Langchain that takes the user's greeting like hello, hi, or how are you as a human message, uses a prompt template to tell the AI to respond politely, and then returns the reply as an AI message. Now let's walk through how does this work. So it starts by sending the greeting. This becomes a human message. A human message. We can also add a system message to guide the AI's behavior. For example, asking it to always be polite. These messages are passed into Langchain's message system, which sends them to a chat model. The chat model uses again the prompt template, and this template includes both static instructions like respond politely and dynamic content based on what user says. Langchain then sends the final input to a large language model such as OpenAI, Google, or Anthropic. The LLM processes the request. The Langchain receives this and returns it to the user as an AI message. This flow shows how easy it is to build a chatbot using a LangChain. You don't need to worry about the technical details of the LLM. LangChain handles everything from managing messages to formatting prompts and connecting to the model. Okay, so to demonstrate what we have seen in the last slide, let's first create a project. I will open a folder. So you should have created the project already, and then it could be of any name. So I have given it a Langchain, but you can give it as any name. So once you have the Langchain, you need to have to create a virtual environment. So for that, I think create a py from m v e m v v e n v. So env. So it has now created a virtual environment file for us where all the script libraries, everything will be under the virtual environment. So once it is still creating it, yeah, the next step is to activate the script where dot slash penv slash scripts slash activate. So now we are in the virtual environment where it has moved into a virtual environment. Now install the line chain first. Pip install Langchain. Yeah, now the Langchain package has been installed. The next package, which also works along with it, is the package core package that also we have to the python.language core, as we described in the previous slide, where this has the base abstractions or the core module. Yeah, the next step is to create an environment variable where you can maintain all your API keys. So in this example, we are planning to use Google Gemini. So let me open our first program, where you see the first step is we are first importing the Google Gemini. So we are trying to make a connection with the Google Gemini and try to have a chat with it. So in Langchain, for this, you have to mention is chat Google Generative API. Tomorrow, if you want to have a chat with the Open AI LLM, then you have to import chat Open AI. So is what. Next step is you want to now create a system message or a human message and the AI message. So here, if you see, for that, these messages are under the core package, where the human message, as you know, it's the user, or it's B who is going to send that message to the LLM. Because if you have a chat, you need to identify who is sending the messages. So the user will be sending the message, the the person who is in the other end, say for example in this case it's a Google Gemini, it will be sending the response back, which we can hold it in the AI message, so that you have the differentiation, like which message are sent by the user, and which ones are written by the uh, LLM. Next step is you have defined your API keys in environment, but you have to load into the memory, or for that we use the load.env file. So you also have to install .env if you have not done earlier. Then you have to load those. After this step, all your API keys will be available to this program. Next is you have defined the chat Google generative AI package, but you also need to mention to which model you want to have a chat with. In this case, I have defined as Gemini 2.5 Flash, so you can have it with Nano Banana or you can have it with Pro, and it's of our choice. So you have to mention to which model you want to have a chat with it. Then I have created a simple message where it says you are a helpful assistant, and then the human message. This is a message which is sent by the user. It's called hello, and the system message is a general condition, like to tell the LLM that he is a very helpful assistance. Or we can have different types of god rails here, like make your response polite and things like that. Once you have defined the message, it's a very simple way to send this message and invoke this the chat is use the chat model where you have created it, and then the invoke function will actually initiate the connection and then passes on our messages to the LLM. So in this case, it has passed the LLM, and then maybe we can try running this. So you can use. I have just now printed the message, so not the response from the LLM. So I just wanted to show what is the parameters which have been passed to the LLM. So here in this case, you see we have passed a system message and a human message, which is hello. Now, if I now print the response, you could see the content. Hello, how can you help you today? This is something received response from the AI. So the response will always, there might be a lot of additional parameters, but the one which is of uh, use is the content. All the content is what the AI message. So AI has replied back saying, "Hello, how can I help you today?" And you can also see the other informations, what model it has used, what are the number of tokens, input tokens, output tokens, total number of tokens. All this information you can see. And then it's to do is I will be appending the message above and then put it as a AI message and the result dot content. So you see the result has a content, and then I am only extracting the content and making it as a AI message. And now if I print messages, maybe I'll clear this first. It's always better to copy and paste. Okay, now if you see, I will just comment it out. Now you can clearly see the system message that what we have set, and then the human message which was sent by us as hello, and then the AI message, hello, how can I help you today? So we are only extracting the content of the response which we received from the LLM. Yeah, we have seen the messages part where you send a message and the response we receive from the LLM, and we only extract the content and put it into the AI message. So in a way that chat can happen. So tomorrow, say if I want to have what is the capital of France, so it actually filters out all the additional response we received but only picks the content value. So you see here the AI message, the capital of France is Paris. That's it. So the only thing which we wanted is the content. Okay, so this demonstrate how the messages happen. So first you have to connect, make the linkage to the to the Google Gemini using the chat Google Generative AI. Then you have to mention the model, on which model you want to have a chat with, and then your messages. So which actually differentiates or it identifies the message which was sent by the user, and then the actual response which is captured in the result dot content. Now, as a next step, we will see how the prompt template works. Maybe we'll create a new file. We will create a new file, prompt example.py. Okay, and then most the Google. So I need this one, and .env. So here I am again making a connection with the Google Gemini, then loading all the environment variables. Next is I'm also need this one. So I'm also mentioning here, so but here I'm showing you the dynamic parameters where name and user input might change, but the template, the prompt remains the same. Only the name and the user input changes. And then this can be passed as a prompt value, and then invoking the template. And then I call the result chat model dot, as I mentioned earlier, what we use is the invoke, and then we pass the prompt value as a so previously we have passed the messages. This time we pass the prompt value. Then let's see what is the result dot content. See, it has responded back because we are only uh, showing the only the content and then filtering out all the additional parameters. So it says my name is Bob, and you can also now put some John. Yeah, you can try it out this simple prompt again. See, he says my name is John. So this is a simple example to illustrate how the prompt templates and the messages work. So in this, you can directly put as, instead of name, you can put it as John. Instead of user input, you can mention it as so. If your prompt is static, you don't have to do this directly. Yeah, when you want to make a static prompt, so previously we saw a dynamic prompt where the in the prompt values we'll be using we'll be we were sending the dynamic values like bomb John, but here I have made the static prompt. This can also be passed the prompt values equal template dot unique, just with no parameters. I'm still invoking that and then passing this prompt values over here. So this is a static. So now I will be executing this static prompt. See here, by default it has, so this demonstrates the static and dynamic prompt, and then we have also seen the messages. So far we have seen two features of Langchain. One is the messages, where you can identify whether it is sent, the message was sent by the user and the or by the AI message. So and you also identify the different roles in the chat while you are creating the chatbot. Yeah, prompt templates, which are reusable structures where you can have a dynamic variables into the prompts. So in my upcoming video, maybe in the next video, we will create an interactive chatbot where you continue to like you do a normal chat with the LLM using the memory, where it will also keep all the history of the chats, and also we can do the chaining. Very important concept in Langchain, where it acts as a modular pipeline where each step performs a task and passes its output to the next. And this helps in creating a complex logic using all the building blocks we have. So these are very important and the core concept of Langchain. So we will see the tools, agents, and the MCP workflow in our upcoming video. Until then, see you.